Hi, welcome back to Engineering Drawing. I am Dr. Vasu. Hope you are enjoying the lectures on engineering drawing. If you want to learn this one and many other interesting topics, please do subscribe this channel. If you like this video, please hit the like button. That will keep me motivated to create many such videos in the future too. Now, let us see the construction of a Epi Cycloid. Okay, so Epi Cycloid means suppose we are traveling, we are standing beside say a flyover, a curved surface, right? And we are seeing a cycle moving on that flyover. That what's happening is this flyover has some curvature, right? We treat this as a part of a circle having some radius capital R, and this cycle which is moving on that is having some certain radius, say small r. So what happens is, suppose we have, this is the flyover or this is the curved path, say, and we have a cycle here, a circle. This circle is moving here without slipping, is rotating and is in contact with this surface. This radius of this arc of a circle is capital R, and this one is a small r. Now when it is rolling, what happens is it moves like this. It moves like this, and the point which is actually here in contact here with the point A on the circle, when it is rolling, it slowly moves up and comes down and it touches the point B again here after making one complete revolution. Now let us take a point on this circle here, right? A point on the circle, and let us see how it moves. The path traced by this point here is called Epi Cycloid. Epi means outside the cycloid. Now, let us draw this. Take some angle here. The angle is obtained with the help of the radius of the circle and the radius of this curvature, right? So, here the angle is taken as 2 pi into small r by capital R gives you this angle theta. Now, I have taken this as capital R and drawn some curve here, and we have taken the circle which is rolling here on top of it. Now the center of the circle is C, and we take a point here on this circle, right? We take some point here which is actually in contact with A, coinciding with A. Now let's divide this circle into some 8 parts, 12, 16, depending on the size of the circle. Whenever you take a number of parts, you get number of points. When you get number of points, it will be easy for you to join by a smooth freehand curve. So divide this circle into, say here in this case, I have taken 8. Name them from this side, 1 dash, 2 dash, 3 dash, like this. So all 8 points are marked. Now divide this circle, this arc. Actually, how much distance it is traveling? This wheel, 2 pi r, the circumference of this circle. That is nothing but 2 pi r. So 2 pi r, basing on that 2 pi r, you can take it, and even you can do one more thing. Take the distance of this point A and 1 dash, and go on from this point, go on marking here at 8 divisions. That's how you can also get the, without calculating anything here, angle. You can just go on intersecting this arc at a number of points, and finally if you mark 8 points, you will get the curve here, the required curve where this circle is rolling. Now let's name these points on this curve as 1, 2, 3 from this side only. 1, 2, 3, 4 up to 8. And we extend these lines here and draw with this point O as center, OC as radius, draw an arc. Because this circle is always at this distance above this curve. So that distance is nothing but small r plus capital R. So this point as center with the OC as radius, you draw an arc. This will be the path where the center of the circle will be moving, right? So let's take different positions here for point the center of the circle C1, C2 like this. How you get it? You can get these points by extending these lines 0, 1, O1. Extend this, you get C1. 0, 2, extend C2. Like this, you get all the points. The center of this circle will be moving on this curve only. Now, draw curves with O as center and O1 as radius. You draw an arc of a circle here. Similarly, through all the points 2 dash, 3 dash, 4 dash, like this, you draw curves passing through all these points. Now, this circle is started rolling. What happens is this path, this curved path A1 is equal to A1, this path, because we have taken the circumference of the circle and divided it into 8 parts. Here also the circumference is divided into 8 parts. So this path from here to 1 dash is nothing but this much. So when the center of the circle C comes to C1, this 1 dash comes and coincides with 1. Okay. And in this case, the point 1 dash is moving down, coming down by this much distance. At the same time, on the other side, this point here move away from the base, from this arc, by how much? By the same distance on the other side. So when you take the next position, the point, the center comes to C1 position, okay? And earlier, this point 1 dash, this is the 1 dash now. It has come and coinciding with 1. So the point, suppose you call it as a P. This point P moves up and moves by this much distance and is always from the radius distance, because this point is on the circle. So from C1, you draw an arc here, intersecting this line, passing through 1 dash. You get some point P1. Follow the same procedure here with the C2 as center and with the small r as radius. Go on to intersect the second line, right? This is the second line passing through second point. Similarly, C3, this C3 as center, third line, third curve. You get a P3, C4, you get a P4, which is on top, right? Because it has made almost a full half circle, half revolution. When it has completed a half revolution, it will this point moves to the top. And once it reaches top, it starts slowly coming down. So P4 comes down when it comes to C5. So C5 as the center. Now small r as radius. You draw the, intersect the arc passing through 5. This one and this one is passing through 5. So intersect here, you get an intersection point P5. Similarly, it has come to C6, cut the or draw an arc onto 6th. This is the 6th. So passing through this curve, we have a curve. So intersect this C6 curve here, you get it. Next, P7. Similarly, P7 on the 7th line, and P8. It of course coincides with B. So like this, you get a number of points on the curve. Once you get all these points, join them all by a smooth freehand curve like this. You get the required curve here. This curve is called Epi Cycloid. Epi means outside the circle. Outside this circle, another circle is rolling. So this is the curve obtained. Now, I want to draw tangent and normal to this curve at some point. You take a point here, some point M here, and join M with, draw an arc with radius small r, the radius of this circle as radius, intersect the center arc, so arc drawn through center C. You get a point. Join this point with O. Okay, this intersects this base arc at some point. From this point, draw a join this point M. So M and are joined. This line, this straight line is nothing but the normal to the curve. Draw a perpendicular line to this normal passing through M. You get a tangent, right? So you got the tangent and normal. Like this, we'll be drawing the curve, epicycloid, and finding the tangent and normal. So in the next video, we are going to see the hypocycloid. Hope you had understood this topic. And if you have any queries or any questions or suggestions, please do comment and do subscribe to get alerts. Thank you.